Hey, hello everyone. Welcome to the session. I'm Pramod Rana, and today I'm going to talk about how to have visibility and security of CI/CD ecosystem. I hope you guys are having a good time at the conference. This is the agenda for today's. First, I'm going to set the context that why I'm having this talk. Second part of that is what is the attack surface around the problem I'm trying to solve here. And then how we can systematically approach that problem in order to figure it out. What's the methodology we can practically follow within our organization. And then I'm going to introduce CICD Guard, which is an open source project trying to solve the problem. What's its architecture? What are the different components which makes that solution? What's the workflow? And then we are going to have a demo. And then I'm going to close the session with the future roadmap for the solution. A bit about me. I am working as an application security manager with Netscope, and we say that security that's ready for everything. We are adamant to secure all the data no matter what. My team is primarily responsible for two domains. The one is the security testing and then having the security integration within the CI/CD pipeline. I'm also author of 3 open source projects, which I have presented in Black Hat, DEF CON, NullCon in different years. I'm also OWASP Pune chapter lead and a proud OSCP. So let me start with the oversimplified version of the CI/CD ecosystem. So for any software in the world, we have a code base which is stored centrally somewhere. And then we have a solution which converts that code base into a deployable entity, which is again stored in a central location on an organization level. And then we have a solution which deploys that entity into the different functional environment. Now, as per the organization nomenclature, that environment can be anything. It can be staging, pre-production, production, QA, or whatever you want to call it in an organization. As a DevSecOps advocate, I'd highly recommend everyone to have these, security integration within each phases of the development lifecycle to make sure that we are delivering a secure and robust software to our end users. And that is security in CI/CD, as we all know it. A very interesting topic, but that's not what I'm talking about today. Today, I'm going to talk about the building blocks of a CI/CD ecosystem and how we can approach the security of those. In today's time, we have number of tools and technologies which makes a CI/CD ecosystem across industry. And most of the time, those technology falls into more than one category. For example, GitHub as an organization started as a SCM, but eventually now with the expansion of the action, they are both into continuous integration and continuous deployment at the same time. And as with any ecosystem in the nature, even if we have the compromise of the smallest piece of that, it's going to impact the entire space one way or other. And that is absolutely true with the CI/CD as well. So we could have a very trivial vulnerability into one of the component, let's say Jenkins default credentials. But if that Jenkins server is responsible for building a business sensitive binary which sits on the client location, that small vulnerability is going to have the impact on the business overall. Part of the problem solving the CI/CD ecosystem is the lack of visibility, as with different domains in the security. For example, in best case scenario, I might be able to tell you that we have 5, let's say Jenkins server in our organization, but it's practically impossible to tell me that how many jobs are actually running on those Jenkins server, let alone what those jobs are doing at any given point of time. Another example could be, are we in a position to tell that how many third-party GitHub actions my organization is using? And even if we have the count of those, can we tell that what kind of versions and what kind of feature we are utilizing by those external GitHub actions? So all of this falls into on a concept level with the asset management of our CI/CD platforms. And another aspect of the challenge is to have the interconnection between the different technologies. For example, eventually, end of the day, we are delivering a software, a single piece of working unit, and anything we do within our entire CI/CD process is with a single endpoint. So all of the points are eventually related, and for example, we might have a vulnerability on a certain code within a certain repo, but if that repository is used by another Jenkins build, which is again further pushed as an artifact to a, let's say, JFrog artifactory or something, then what is happening is that there is a connection between GitHub repository or any SCM to a build process, Jenkins, Bamboo, and then having a to the artifact server. So that interrelation is very difficult in on an organization level. If we have multiple tools around those multiple technologies, making that overall process, then it becomes difficult with over the period of time to find the relation and all. Let's, I have already given few examples around that. Let's try to summarize it in an easy way. Here in this example also, like I said, the vulnerability is very trivial, but again, depending on the functionality and the role of that Jenkins server, it can have impact on the business level. The same goes for let's say we are using a malicious or vulnerable third-party action running in self-hosted runners. I remember yesterday only there was a talk about that, where the third-party actions can have impact on organization, crypto mining or any other used way, and all of that in a way relates to the visibility part of the problem, where we are trying to identify that what and how we are using it. Another example could be, let's say we have users, we have a single user provisioning system, and then each of the user is provisioned in the same way in a different technologies. For example, if it gets compromised on one technology, then how it can impact the other parts as well. So I'm putting the name to the technology here, but it applies on a more holistic way. For example, I'm saying GitHub, but it could be any other technology. That's what I have put it intentionally, because that's kind of well known in our industry. Another aspect could be, for example, as a security practitioner, we all aware that we should have a multi-factor authentication on any kind of enterprise level software we have. If we do not have that feature enabled, that is the process part of it. The other part of it is that how do we make sure that the setting be there all the time, the governance part of the problem. And if that doesn't happen, then with a different kind of attack, that can have impact on the organization. So how do we approach that problem? I think there are three parts to it when we say the methodology. The first is making the software secure, inherently by default. When I say software here, I'm using it in a very generic term. It could be as small as a library doing a very, very specific job, to the point it's an enterprise level SASE product, which is getting used by every single employee of the organization. For example, Workday. Making the software secure by default in a way lies with the responsibility lies with the software provider. Whoever is developing software, it's a common understanding that organization is responsible for that. That is eventually security in CICD domain. But what I would like to propose is that it's too much of a task for any single organization to ask to make the software secure all the time, especially in current times. So I think there are two parts to it. The one is the provider and the other part is the end user. As an end user also, we are in a way responsible to make sure that whatever we are using have a certain security vetted process. And on an organization level, it makes more sense. So what we have done within our organization is that whenever we are onboarding a third-party component, like I said, it could be anything, a single library to an enterprise level software. We make sure that it goes through a certain security vetting process where we understand that how the security posture of that particular product looks like. Second part of that thing is when we identify something, I think it's it's our obligation, more or less, to work with the software provider to fix that vulnerability as if it's our own product vulnerability. So that is the first aspect of the overall methodology, that we work towards making the software secure holistically as a community, where everyone, the provider and the end user, both are responsible for securing the product. The second aspect of methodology is that the implementation part. So a product can be best secure inherently, but if we are not configuring it well, eventually it's going to fall apart. For example, Jenkins might have the best versions available, but if we leave anonymous access, it doesn't make sense. So I think the second part is how well we are implementing it within our organization, and that will vary as per the organization. It's a diverse problem to handle. For example, it could be as simple as disabling the default settings, using the MFA, or up-to-date plugins, apps, actions. I think most enterprise level software has plugins in a way to extend the functionality of the software, and those are kind of notorious things to have in the environment, because as we expand on the functionality, it becomes a challenge with the security. The more flexibility we give to the software and we expand it to the community, we expand on the functionality, but at the same time, it becomes challenging for the security part. So I think once we have that aspect, we keep it up to date. It's a nightmare to keep up to date all the plugins within the organization, but I think we can approach on that part. The third aspect of that is monitoring part. Like I said before, the governance part. Let's say we have a policy which says that everything which comes to our organization has to be security vetted. And in the process, we identified something which we need to fix, which we did from the second point, technical aspect. But how do we make sure that that setting or that configuration sustains over the period of time? We might say that we need to enable the MFA on the GitHub for all the users, but any admin user can change it, or can we make it this way that nobody can change it with any permission? So monitoring part becomes very important over the period of time, because as a security professional, we all could agree that no matter how much we try, eventually something bad will happen. In that case, how we can respond effectively if something happens? So that is the methodology on a high level. First, making the secure software inherently by default with the contribution of everyone, provider and the end user. Second part is implementing it well, not doing any misconfiguration. And the second part is continuously monitoring and being effective in responding whenever something happens. So that's where CICD Guard comes into the picture. It's an open source project which I'll be releasing after this talk. It does, on a functional level, it operates in three aspects. First is it represents each component of the technology into the graph format. And what I mean by that, it is goes to the granular level, the most granular level possible for each technology, and tries to break down the technology in terms of graph. And then we have a relationship between those nodes, which represents that how the configuration is done for that particular technology. For example, let's pick the example of GitHub Action. In GitHub Action, as we all know, we have workflows, and then we have jobs, then we have steps, then we have another action, then we have runners. So all of those are node type in CICD, and how those are configured within the environment will represent the relationship between those nodes. So that is the first aspect, trying to solve the problem of the visibility part. Second, it identifies the security misconfiguration in the implementation as per the industry best practices, whatever as per I have been able to done through my research. So all of these data, when I say knowledge base of the vulnerability, will be available in the GitHub once I publish it. So it tries to identify the security misconfiguration in the implementation. And the third aspect is, which is I think the most important in context of CI/CD guide, it tries to identify the relationship between the different technologies. The example I mentioned, that a particular repository triggering Jenkins job, then what it will do is it will read the build, it will try to identify which repository triggered it, and then make a relationship on the graph theory level. So there will be a edge connecting both of those nodes, so that we know that these are the inter-technology relationship between them, and that applies to inter-technology relationship as well. Now let's consider a scenario on an organization level. We developed a policy that whenever we are using a third-party action, we are going to analyze it, and on the basis of a security analysis, we are going to pinpoint to a certain version, that this is the version which is certified by security. Now let's consider that that particular third-party action is used by 10 teams, and each team is in a way using a different version. So what CICD guard is going to do is it's going to build the nodes for each version, so that from a governance side, you know that we as a security team certified this particular version, whether the organization, all the teams within the organization is using that version or not. So you can pinpoint on that version and identify all the nodes which are not using that version. So that's the relationship part comes into the picture. So example of that, like I mentioned, Jenkins jobs getting triggered by the repository. Are we using weighted version of external GitHub action? Do we have common users between Jenkins, JFrog, so on and so forth? Technology could be different. So these are the three aspects, representing everything in graph, breaking it down to the lowest level possible for each technology, try to identify the security misconfiguration for those nodes, and then identify the relationship across the technologies. Now the relationship could be like in case of GitHub, I could have an enterprise organization level node. That organization level node have multiple repositories all connected, and then each nodes will have, let's say, group of users who is assigned to the repository. So using the graph theory, it enabled this tool to have that relationship in a relatively easier way to visualize and impact. Like I said, this is the node database schema. Like I said, it breaks down to the lowest level possible. And for example, let's say if I make an action node, which is used by another workflow, then eventually it will have a circular relationship with that node, so that we are aware that this action is getting used by another action in one way or other as well. This is what the architecture or the different components of the solution looks like. Before we go forward, any question for me? Let me catch my water. No? Yeah, please. What do you mean by where to ask? You mean in terms of technology?
Login or whatever they try to.
No, so in case of multi-factor, that will be on the user account level. Whenever you do something, whenever you on the lowest level, whenever you make an API call to any service, you need to have MFA. I know it will vary as per the technologies. For example, if you need to make an API call programmatically, like I'm doing in this code, I need to have access token associated with that. In that case, the security policies will vary. For example, for the access token, you could say that it has to be rotated within a certain period of time, because we cannot have MFA there. So it will vary how we are utilizing the technology in order to make the communication between that. Okay, moving forward. There are four broad components to this solution. The first is the scan engine on the left hand side. I have kept scan engine in a way that it can be used on isolated manner as well. And what I mean by that is that there are, at this point of time, there are four scanners doing different jobs: GitHub, Jenkins, GitHub Action, Jenkins, and JFrog. And each scanner can be used individually. You do not need to, there is no dependency between all of these tools. Eventually, if you use all the scanners, it will help to build the analysis or the relationship. But if you want to use it for a very specific technology, it allows to do that function as well. The second component is the analysis. Like I said, if you start using more and more, the analysis engine will be able to fetch the data and make the relationship between the different technologies. Now, that relationship could be anything. It could be between N technologies to M technologies. From the output perspective, in order to make the relationship, it has to be stored in Neo4j data, which is a graph-based database I am using. But if you want to use those scanners individually, then you can, have the output in the JSON format, which is again machine readable. You can redirect that output into a third-party solution, for example, Elasticsearch. So there are two ways. Like I said, there are two ways to use it. Use it individually, parse the data into JSON, and then send it to somewhere else where you would like to have the analysis. Second is you use all of that, put into the Neo4j and build the relationship. And you can use in both ways as well at the same time. There is a very simplistic web UI at this point of time, which helps us to talk to the database and make some basic filtering around the UI part. From the input perspective, there are two ways you can provide the input to the scripts. One is the environment variables, and you can do the same via the command line as well. Environment was specifically if you want to have the integration with the other solutions, so that you can pass it there and then run it, not stored or getting passed into the command line sensitive information, because most of the scanner will require your authentication detail in order to work effectively. Not most, I'd say all. Demo. I intentionally recorded this demo for specific reason that I needed to redact the data, what I am going to present here, because I did not want to show it. I cannot show it in a live conference which is getting recorded. Obviously, I can run it with my personal GitHub account, but then the data will be too minimal to make any sense out of it. As you can see, those independent scripts are the 4 scanners which can be run. First, I'm going to run the GitHub Action scanner. And the primary reason of making 2 scanners for GitHub and GitHub Action is because logically those both are serving different purposes. So rather than segregating on the technology basis, I segregated on the basis of the role functionality. And both scanners will have different input as per the role of that particular technology. For the demo purposes, I am using environment variable as an input. For example, for the GitHub Action, you have to provide the organization and the repository name, which particular repository you want to be get analyzed with the action. And whenever you see data in the square brackets in the output, it basically represents the correct data. I just have redacted. So if you will run it in a real life, you will see the actual organization name which is getting created. So whenever a scan gets started, it creates the node and then display the information that what kind of node is getting created. And then when there is a vulnerability identified specific to any node, that information gets appended into the database. So this is the JSON format I was telling you, which getting displayed in the command line. You can easily redirect to a file or something and then store it. Second, and it's pretty fast for given the access and all. Second, I'm going to run is the Jenkins one, which is concept is same. You provide the authentication detail on the basis of technology is going to identify, it's going to create the nodes depending on what technology you are providing. Sometimes it takes time depending on how many API network call we are making. We created different nodes. Is it visible in the back? Okay, thanks. And then once it gets into, let's say example, to the Jenkins technology, it's going to process all the jobs, and then within job, it's going to process all the builds. So the node structure will look something like this: Jenkins servers, associated jobs, associated builds with each job. So the graph will look something like this. Server to connected to job, and then job is connected to build, and then build eventually connected to the node, which is responsible for running that build. And then so what's going to happen with the graph is that if a single node is running, let's say 10 builds, eventually that single node will be connected to the 10 different build nodes, so that you know that the node in context of Jenkins is running too many builds at any given point of time. Now the second thing, it processed the user list. Again, Jenkins server will be connected to the group node, and then group node will be connected to the user node, so that you know that within each group how many users you have and how many users are there in different groups, because every relationship, every edge is circularly connected as well. Yes. So what I do is every node obviously has some metadata, and when you go to the UI, you can select that node, and when you select any node, information will be displayed. And depending on the metadata of that node, you can make a selection whether it was a last build or not. When it comes to the data associated with the node, there are two type of information. One which I'm able to fetch it from the tool directly. Second, which I'm assigning through the code. So all of those information makes the metadata of any particular node. Since it's processing a lot of users, that's the reason it's taking time to execute the process. Now again, the output is in JSON and a different way. As you can see in the code, it processed all the plugins of the Jenkins server. So how it's going to, so what the use case practically here is, for example, like I said, you have 3 Jenkins servers. In 3 Jenkins servers, you have, let's say, 10 plugins. Now what is going to happen is that for each plugin type, it's going to create one node, and each plugin will have an edge to the server with which it is installed, so that you know that in my organization, I'm using plugin A, which is used by Jenkins ABC, and A has version 1, B has version 1, but C has version 2. So that kind of information, it will help you to identify when you convert it into the graph. Now this is what the UI looks like. Like I said, it's a very minimalistic UI at this point of time, which broadly has 3 sections. One is where the graph is displayed actually, and graph can become quite messy if you scan, let's say, 10 technologies at the point of time, because I'm breaking down it to the lowest level possible. So that's why I have the second section, the filter one, where you make the filter on the basis of the technology or basis of the node you want to see and analyze at any given point of time. And then obviously there are some node details, information, colors, which each color represents and all. So this is the filter you can use to identify that which node you want to see at any given point of time. For now, the filter is on the basis of the type of the node. Currently, I'm working on a feature where there is a search where you can identify the node on the basis of more metadata. For example, it could be something like type equals to repository and name equals to ABC, or it could be username equals to ABC and technology equals to Jenkins, so something like that. So I'm working on that search feature, which will help us to figure out the point in interest node at any given point of time. So for example, if you make a filter, it's going to select all the plugins. Search is OR at this point of time, OR condition. If you select 2 technologies, it's going to display A or B, both nodes. Red color represents obviously the vulnerable node impacted by the code. Like I said, it's our condition. It's showing both the nodes. Now it's showing the builds only. If you not select anything, it will show everything. interesting thing I want to show you here is the connection part. Like I said, the interconnection between the different technologies. If you look at the bottom graph, there is a black node connected to, I don't know what to call it, bluish color node. This node is GitHub repository node, and this node is Jenkins build node. So what is happening here is that it identified the relationship between a repository and the Jenkins build. Now same will apply as we will keep growing in terms of the expansion of the target technologies. The more technologies we scan, the better relationship will be able to build between them. So if you have used only GitHub, then obviously it will not find a relationship with other. But if you used GitHub and Jenkins, then it's going to find the relationship between them. If you used GitHub, Jenkins, and JFrog, then it's going to find the relation between JFrog and GitHub, so on and so forth. That combination will be there always. So like I said, the scan engine is independent of the analysis, but eventually relies on the data which the scan engine is providing. If you recall the architecture part. So same, there were two distinct relationships which it was able to identify. So that was the demo. Before I go into the future roadmap, any question? Yeah. Okay. Okay, sure. The question is that CICD at this point of time is in a way endpoint solution. How do we make sure that it is continuously getting scanned and then obviously getting alerted whenever there is something? Right now, we have scripts which can do the scan at any given point of time. One way of doing it is that we use that script in another tool which allows us to run that script continuously. For example, we can build a continuous job in Jenkins or Action which can run that script and then rely on that technology to make the alert and everything for us. If we want to have that feature enabled with the CI/CD guard as well, then what I will need to do is that expand on the configuration part more. So what I can do is that I can provide a feature which enables us to do this continuous scanning. But I think that's not what would be, I'll say, there's no point of, in my opinion, there's no point of reinventing the wheel. So what I'm trying to focus right now is build on the, to expand on the technology part as a going forward, expand on the technology part, and rely on existing tools which are already there, which can do the job of the continuous scanning or continuous alerting. For example, it would be very straightforward process to configure a job in the Jenkins to run this script and do the alerting part. So that's how I'm seeing it. That expansion on the technology part more, the relationship part more, then expanding on a thing which, in my opinion, the tools can already do. Make sense? Mm-hmm. Mm-hmm. Fair enough. Fair enough. So the question is that we do not change, let's say job manually going to the platform and do it. It's all orchestrated through the code, correct? So what we can do in that scenario is that we integrate the independent scripts into the existing process itself. And I think that's what my point was also. Like, we already have a process to build the software in one way or other. I mean, you said infrastructure as a code as an example, like not changing a job. But so I think if we focus on making the security tools as light as possible and fit it into the process. So if I tell a DevOps engineer that I have a separate tool which you need to integrate into your environment and which will alert me if something bad happens, by doing any changes and all. Other approach, I think, is that I tell them that this is a small piece of thing which you need to put it into your progress. And if something happens, it will do the job for me automatically. So what can we do is that since you are managing all your configuration in terms of code, and when there is a code, there must be a process to identify the change. For example, pull request in case of GitHub. I just tell them when there is a pull request, you are supposed to run this script as well. How we do it technically? GitHub Actions. Again, if the code base is in GitHub, then we utilize the GitHub action. And then with each PR, we build an action which will run this script and do the trigger for us. So I'm intentionally keeping the UI part as light as possible and make it, more modular so that it can be used in a different combination. And that was the primary reason of making scan engine isolated, that it does not rely on anything. Each script are independent scripts on own, and if you run it collectively, it will give you a different data insight in order to analyze. Yeah, please. Good question. If I'll give you my organization example. So like, we do development in a crazy speed, and it's practically impossible, like I said, to introduce a new process from the security side and then keep up with that. It's not going to happen. And I think it's true for most organizations in today's time. I expect it to be part of the DevOps process. And it will again come to the modular part of the solution. So if we have a solution which is modular enough to fit into the requirement of each organization, like I mentioned few technology which it is supporting at this point of time, but none of the organization is going to use the same set of technology. Every organization will have their own way of doing it. So if we segregate it on an individual level and the input will be diverse, and somehow we make the process so that it redirects to a single output source. So two use cases to use it. The first is that you use individual things integrated within the DevOps process and parse the data as you like it, as per your organization requirement. Second is you again use it on an individual level and then push all the data into a single database, which would be Neo4j in this case. But short answer, I expect it to be integrated within DevOps rather than having a security thing. Did I answer? Thanks. Any other question? Okay. For the roadmap part, expansion, obviously, target technologies, the more I expand it, the more it will be able to, be more effective in terms of data and everything. These are the few I have in pipeline, but it will depend on the environment and all. It's little difficult to get the testing environment and everything. And then the tool has to be API supported and all, because technically everything is API communicated for CICD guard. Second part, which I think I personally am very much interested, is the analysis part, expansion on that. Process more and more data associated with each node so that the relationship can be more, more impactful. For example, what is the correlation between different repositories? One example could be in case of a microservice based architecture of the platform, that one service can be built by multiple repositories, or one repository can contribute to multiple microservices. So can we convert that data into graph so that it helps us to build that relationship? And for that, we will need to process more and more metadata of the GitHub provided by GitHub or built by our own algorithm. And it could be something like this on a theory level, that 5 repositories is building a microservice A, which is getting pushed to Artifactory B, which is getting deployed into production environment and pre-prod. So there is a relationship starting from the repository, and then we trace it back to the user level as well, that user A, B, C contributed to repos A, B, C, D, and then all of that contribution got converted into a microservices, which was again stored as a binary into different environment. So if we are able to process data deep enough, then we will be able to contribute that what changes of the code ended up into your customer environment. The third part of that is obviously the visualization search is, I think, the most practical and the usable thing would be, rather than making fancy graph around it. I think the more search feature we have within our organization, it will be, because I just scanned, I think, 5 repos, 2 Jenkins servers and 1 JFrog Artifactory, and the data was that messy. So if we do it on an organization level, it's going to be messy to look at it in a single view. So I think that's where the search feature will be more practical to use. Yeah, so that's all I had from my side. If you have any question, we can talk about that.
Thank you very much.
Yeah. If you have any question after the session, as always, you can reach out to me via this mediums. I'm more than happy to discuss about it.
So we did a lot of questions throughout the talk, but just open up for a general Q&A. If anyone else has any remainder questions, we have 5 minutes for that now.
The code I will be releasing after this talk, maybe today or once I'm back home. It will be available to this URL.
Any questions? Oh, thanks again. Really appreciate it.
Thank you so much. You have been wonderful audience.